What's up, guys? We're going to continue working on these functions. So today for section 4, it's graphing a function rule. Now there's a few ways to do this. I'm going to start you off with just one way and then we'll move on from there. It says, what is the graph of the function rule negative 2x plus 1? Here's the steps for now that I want you to do, is to make a table. So we'll start with an x, y. You really could just make a t-chart. And what I'd like you to get in the habit of doing is making a couple negatives, 0, and then a couple positives. Now I use these as my basic ones just because they're easy to work with. I could do this with middle math. So negative 2 times negative 2 is 4, plus 1 makes that 5. Negative 2 times negative 1 is 2, plus 1 is 3. 0 times negative 2 plus 1 is 1. 1 times negative 2 would be negative 1, and then this is negative 3. So hopefully you didn't have any issues doing that. Then it says to graph the ordered pair. So I'm trying to write the graph of this. I go through and just plot these points. So I have negative 2, 5. I have negative 1, 3. Then I have 0, 1. Then I have 1, negative 1. And then I have 2, negative 2. Now this is a linear function because it goes on a line. I'm going to do my best to draw that line. There we go. That's not bad. All right, so that's how you would graph that particular function by making a table. It's literally, you get to pick the values. Now this is one of the things that students really struggle with when I tell them make a table. They're like, well, what numbers do I use? You use any numbers you want. It doesn't matter. I usually like to pick numbers that are going to make it a little bit easier, but you could pick like 67 or something like that. I don't know why you would, but you could. All right, here's one for you to try. Go ahead and pause and give this one a go. All right, so here's what I got on this one. Now you'll notice here I picked a little bit different numbers, and the reason I did that is because of this denominator 2. I picked numbers that I know are divisible by 2, and it just makes it a little bit easier. If you didn't do that, if you still did negative 2, negative 1, 0, 1, and 2, it wouldn't be a big deal. You'd just be dealing with these like half spots here, where you'd have something graphed here and something graphed here. I like making my graphs where everything is an integer, because when I use grid paper, it makes it a lot easier. All right, again, I want to kind of wrong if you did that, but, you know, kind of look ahead a little bit and think, wow, what could I do that would make this maybe a little bit easier? Here's an informative pie chart for you to look at. I like action movies, you know, they got like all the fighting and the army stuff and all that, and I found this chart. I thought it was really good. This is what helicopters typically do in action movies. So you'll see like the helicopter come flying by or something like that. This is the purpose that they serve. This is a good pie chart that breaks it down for you. They explode. That's it. You see a helicopter in an action movie, it's exploding. All right, so graphing a real-world function, it says the function rule W equals 146C plus 30,000 represents the total weight W in pounds of a concrete mixer truck that carries C cubic feet of concrete. If the capacity of the truck is about 200 feet cubed, what is a reasonable graph of the function rule? Well, in order for it to be reasonable, you have to kind of look at a few things. First of all, notice that these numbers are really, really large. And you're going to get pretty big numbers when you're talking about weight for a concrete truck. So I'm going to pick some larger numbers to go along my x-axis here. I'm going to say something like 20,000, 2, 3, then 1, 2, 3, 4. We'll make this one 40,000. And then 1, 2, 3, 4. And we'll say the top is going to be 80,000. And you'll see why this makes sense in just a second. All right, so down here, I want to have values. We'll go up by 50s. So 50 on every other, 100, 150, 200. And we're going to stop there because it says the capacity is about 200 feet cubed. So the first thing you were asked to do is to make a table. Well, I have C, and then I have W. So here are my W values. Those are my weights. And then here are my C values. And I'll start at 0. And then we'll go up by these increments of 50. So I have 50, 100, 150, and 200. I could make a lot more than that, but it wouldn't really be necessary. If I went up by each specific foot, because you're talking about up to 200 pounds, that's going to be a huge table. It's going to be a ton of points to plot, so it's not really valuable to us. All right, so we'll take a look at this first one. When it's 0, that's going to be 30,000 tons in weight. If I go and I make it 50 pounds, I put that right here, and that's going to give me 37,300. I'm kind of cheating here and looking off the paper I have, but you should work it out. This one, if I add that together, is going to be 44,600. 150 is 51,900. And 59,200. Is that right? Yeah, 59,200 for that last one. So there are my points that I could plot. It says, what is a reasonable graph of the function rule? Well, I don't want to go beyond 200. That's not reasonable because the capacity is 200. I don't want to go below 0 because, well, I can't have negative cubic feet of concrete in the truck. So this is a reasonable table. A reasonable graph is only going to happen in this first quadrant. So here are my points. I'll go through and we'll plot those. So there's 30,000. When it's 50, it's about 37-ish, something. We'll say that is right in this range. And then 100 is 44. So they say that's pretty close to that. It's going to be about 45. 150 is 5190. So I'm getting closer here. 200 is close to 60,000, which is going to be somewhere in this ballpark. And actually, I think my dots might be a little bit off. I'm having a hard time seeing that, but I think you get the idea. All right, so that's a reasonable graph, and it would stop at 200 because it's not going to go any more than that. All right, we need to talk about this idea of continuous and discrete. This is a continuous graph. Make sure you pause and copy this down. Continuous graph has no breaks in it. It is not broken. A discrete graph is dots. And there comes up different situations where a continuous graph makes sense and a continuous graph makes sense, or a discrete graph makes sense. So here's a situation, a couple situations to look at. It says a local cheesemaker is making cheese to sell at a farmer's market. The amount of milk used to make the cheese and the price at which he sells the cheese are shown. Is the graph continuous or discrete? So if I were to graph this first one, 1 gallon of milk makes 16 ounces of cheese. If I'm going to graph this, I can use something in, like if I'm going here and I have 1 gallon and then I have 2 gallons, I could use 1.5 gallons of milk. I could use 1 3/4. I could use 1 7/8. I mean, I could really go through a lot of different things. So 1 gallon's going to make that. This graph's going to look something like this. And because I could use in between gallons and I don't have to do exactly 1 gallon and exactly 2 gallons and so on, this is a continuous situation. All right, a continuous graph would work on this. If I come down here and it says each wheel of cheese costs $9, and I'm going to graph that, I'd have 1, 2, and 3. I sell a wheel of cheese. That's it. Okay, so I sell 1 wheel, and it costs something. I sell another wheel. It costs something. I don't sell a wheel and a half. I don't sell a wheel and a fourth or anything like that. I'm selling specific amounts that I can't have in between. So if there's no value that you could have in between, we call that discrete. Okay, so that's the situation. Oftentimes, if you have a graph that's dealing with people, how many people can ride in the bus? That's going to be a discrete graph because you can't have 1.5 persons on the bus. You have a person or you have another person, but you don't have anything in the middle. Graphing nonlinear functions. So this is the same thing. You just make a table. So we'll do our x and our y. I'll pick a couple values. And I just put those in there. So -2, absolute value of that's 2. Absolute value -1's 1. That's 0. That's 1. And that's 2. And then I just sketch the ordered pairs. So I have -2, 2. I have -1, 1. I have 0, 1, 1, and that. And you could kind of see that it looks like this pattern would probably continue. So that the graph of this absolute value is going to look like this. So that one's not too bad. Make sure you have that copied down. It's just a matter of making a table and plotting points. Here's one for you to try. Go ahead and pause and give this one a go. All right, so here is what I got. Take a look at this. There's my table. There's my graph. This, by the way, is called a parabola. We're going to spend a lot of time on this later in the year, but that's kind of an important shape where these things continue going. So make the table. You kind of see how it swoops down, kind of makes like a U shape. And yep, that's it for today. So hopefully you took good notes. I will see you in class.